Have you ever looked up at the night sky and wondered just how far away those tiny specks of light really are? It's a simple question, but the answer is the key to unlocking almost every secret the universe holds. You might think, okay, so a star is far away. What's the big deal? Well, it's a massive deal. In fact, without knowing the distance to celestial objects, the entire field of astronomy would pretty much fall apart. Imagine this. You see a light in the sky. Is it a small, dim star that's relatively close to us, like a neighbor down the street? Or is it an incredibly bright, massive star that's just so far away it looks tiny, like a lighthouse seen from across an entire ocean? Without knowing the distance, you can't tell the difference. You can't figure out its true size, its brightness, or what kind of star it even is. Distance is the fundamental yardstick of the cosmos. So, how do we actually use this cosmic yardstick? Well, once we know how far away a star is, we can finally calculate its intrinsic brightness, or what astronomers call its absolute magnitude. This tells us how much energy the star is actually pumping out. From there, we can figure out its size, its mass, and even its age. Suddenly, that little speck of light has a story, a history, a place in the grand cosmic family tree. It's no longer just a dot. It's a colossal ball of fusing plasma, perhaps hundreds of times larger than our own sun. But it gets even more profound. Measuring distances doesn't just tell us about individual stars. It tells us about the universe itself. Take galaxies, for example. In the 1920s, the great astronomer Edwin Hubble was measuring the distances to faint, fuzzy patches in the sky called nebulae. He discovered they were actually entire galaxies, just like our own Milky Way, but incredibly far away. And he noticed something else, something that changed our understanding of reality forever. The farther away a galaxy was, the faster it was moving away from us. This wasn't just random movement. This was the signature of an expanding universe. The very fabric of space-time is stretching, carrying all the galaxies along with it. And how did we discover this? By measuring their distances and their speeds. Without that crucial distance information, we'd still be thinking we were in a static, unchanging universe. This discovery led directly to the Big Bang Theory. If everything is moving apart now, it means that in the past, everything must have been incredibly close together. By measuring the rate of expansion, the Hubble constant, we can rewind the cosmic clock. We can calculate the age of the universe itself. Right now, our best estimate is about 13.8 billion years. That number, the age of everything, comes directly from measuring distances to faraway galaxies. It's mind-boggling when you think about it. The answer to how old is everything is written in the light from the most distant objects we can see. And the story doesn't end there. In the late 1990s, astronomers were trying to precisely measure the expansion rate to see if the universe's expansion was slowing down due to gravity, as everyone expected. They used a specific type of exploding star, a type Ia supernova, as a standard candle to measure vast cosmic distances. What they found was shocking. Not only was the universe not slowing down, but its expansion was actually speeding up. It's accelerating. Something is pushing the universe apart, working against gravity. Scientists call this mysterious force dark energy, and it makes up about 70% of the entire universe. We have no idea what it is, but we know it exists because of its effect on the expansion of space over immense distances. Again, this revolutionary discovery, one of the biggest mysteries in all of science, was only possible because we could accurately measure just how far away things are. So, why does measuring distance in space matter? Because it tells us how big stars are. It tells us how fast galaxies are moving. It tells us how old the universe is. It reveals the existence of mysterious forces like dark energy. It even helps us predict the ultimate fate of the cosmos. Will it expand forever? Will it collapse back in on itself? The answers are hidden in the distances. From a simple point of light to the grandest questions of existence, distance is the thread that ties it all together. It's the foundation upon which all of our cosmic knowledge is built. So the next time you gaze at the stars, remember you're not just looking at lights. You're looking at distances that hold the secrets to everything. Thanks for watching, and don't forget to look up.